When American doughboys stumbled through the suffocating fog of the Western Front in 1918, their standard-issue rifles became nearly useless beyond 20 yards. Yet one weapon defied the blinding mist that turned battlefields into deadly mazes of confusion and friendly fire. The Winchester Model, 1897 trench gun underwent a seemingly minor modification that would revolutionize close-quarters combat effectiveness in zero-visibility conditions. This wasn't just another military upgrade. It was a precision engineering solution that doubled the probability of hitting targets when soldiers couldn't see beyond their own outstretched hands. The acrid smell of cordite mixed with the metallic taste of fear as Private James Morrison crouched in a shell crater near Belleau Wood, his modified M97 clutched against his chest. Around him, the morning fog rolled like a living thing, swallowing entire squads and turning the battlefield into a ghostly labyrinth where death whispered from every direction. What transformed this pump-action shotgun from a standard trench-clearing tool into a fog-penetrating precision instrument was a deceptively simple barrel modification called a choke. This was a slight constriction at the muzzle that would prove to be one of the most effective combat innovations of the Great War, fundamentally changing how infantry engaged in low-visibility warfare. The Winchester Model 1897 arrived on European battlefields as America entered the war in 1917, initially designed for hunting waterfowl in the marshlands of the American South. Military procurement officers recognized its potential for trench warfare, where engagements occurred at distances measured in yards rather than hundreds of meters. The standard military configuration featured a 20-inch barrel, a 6-shot tubular magazine, and the distinctive external hammer that gave the weapon its aggressive profile. Soldiers could fire all 6 rounds in under 3 seconds using the slam fire technique, where holding the trigger while rapidly cycling the pump action created a devastating stream of buckshot. However, the weapon's effectiveness diminished dramatically in the fog-shrouded battlefields of France and Belgium. Standard military loads scattered shot pellets in a wide pattern, designed for maximum coverage at close range. While this spread pattern proved devastating in clear conditions within trenches, the same dispersion became a liability when visibility dropped to mere feet. Soldiers found themselves firing blind into the mist, with most pellets missing their intended targets entirely. The problem wasn't just tactical, it was mathematical. A standard cylinder bore scattered 9.33 caliber buckshot pellets across a 30-inch circle at 25 yards. In fog, where targets appeared as fleeting shadows and muzzle flashes, this wide dispersion meant that only 2 or 3 pellets might strike a human-sized target. The remaining pellets disappeared harmlessly into the mist, wasting precious ammunition and revealing the shooter's position without guaranteeing a decisive hit. Military engineers studying combat reports from the Argonne Forest and Chateau Thierry identified a critical gap in infantry effectiveness during dawn and dusk engagements, when fog and smoke created near-zero visibility conditions that favored defensive positions. The solution emerged from an unlikely source: American waterfowl hunters who had spent decades perfecting techniques for shooting ducks and geese in foggy marsh conditions. These civilian sportsmen had long understood that successful hunting in low visibility required concentrating shot patterns rather than spreading them wide. Their secret weapon was the choke. This was a gradual constriction of the barrel's interior diameter in the final few inches before the muzzle. Master gunsmith Samuel Richardson, working at the Winchester factory in New Haven, Connecticut, had been experimenting with choke modifications since 1915. His background crafting custom hunting shotguns for wealthy sportsmen provided the technical foundation for what would become a military breakthrough. Richardson understood that by reducing the barrel's internal diameter from .729 inches to .710 inches over the final 2 inches, he could force the shot column to maintain cohesion for significantly greater distances. The physics were elegant in their simplicity. As shot pellets traveled down the barrel, they naturally began to spread due to air resistance and slight variations in individual pellet velocity. The choke acted like a focusing lens, gently compressing the shot column just before it left the muzzle. This compression didn't increase velocity, it increased density. Instead of spreading into a 30-inch circle at 25 yards, the modified pattern concentrated into a 15-inch circle, effectively quadrupling the pellet density within the target area. Richardson's initial prototypes underwent testing at the Aberdeen Proving Ground in Maryland during the winter of 1917 to 1918. Test results exceeded all expectations, showing consistent improvement in hit probability across various visibility conditions. The first combat trials occurred during the Second Battle of the Marne in July 1918, when Sergeant Michael O'Brien's squad received 12 modified M97 shotguns for evaluation. O'Brien, a former duck hunter from Louisiana's Atchafalaya Basin, immediately recognized the weapon's potential. His combat report, filed 3 weeks later, would become legendary among military procurement officers. The choked guns hit like hammers in the fog. Where we used to pray and spray, now we point and kill. The modification process required precision machining that pushed 1918 manufacturing capabilities to their limits. Each barrel underwent careful measurement and gradual boring to achieve the exact .710-inch diameter. Too much constriction would create dangerous pressure buildup. Too little would provide no benefit. Winchester's Quality Control Department rejected nearly 30% of modified barrels during initial production, as tolerances measured in thousandths of an inch determined the difference between a superior weapon and a dangerous malfunction. Production challenges mounted as demand increased. The choke modification required an additional 45 minutes of machining time per barrel, straining Winchester's capacity to meet military contracts. Factory workers, many of them women who had replaced men sent to France, learned to operate precision boring machines with remarkable skill. Mary Catherine Sullivan, a former textile worker from Hartford, became one of the most skilled choke specialists, consistently producing barrels that exceeded military specifications. The modified weapons began reaching frontline units in August 1918, just as the 100 Days Offensive commenced. Initial distribution prioritized assault troops and trench raiders, who operated in the pre-dawn hours when fog provided natural concealment for both attackers and defenders. Combat effectiveness reports from the Meuse-Argonne Offensive revealed the choke modification's true impact. Lieutenant Colonel Harrison Webb, commanding the 2nd Battalion, 5th Marines, documented engagement outcomes with scientific precision. His unit, equipped with 36 choked M97s, achieved an 87% hit rate during fog-obscured assaults, compared to 31% for units using standard cylinder bore weapons. The mathematical advantage became apparent in life-or-death situations. During the assault on Hill 142, Corporal Thomas Mackenzie engaged 6 German soldiers emerging from a communication trench in heavy morning fog. His choked M97, loaded with military buckshot, delivered all 9 pellets into a 12-inch group at 18 yards. The concentrated pattern proved instantly decisive, whereas a standard weapon would have scattered pellets across a 24-inch area, likely requiring multiple shots to achieve the same result. German forces quickly recognized the modified weapon's effectiveness. Captured documents from the 5th Bavarian Reserve Division specifically warned about American fog guns that maintained accuracy in conditions where rifle fire became ineffective. One German officer's diary, recovered near Sedan, described the psychological impact. "The Americans have learned to kill in the mist. Their shotguns speak with authority when our rifles fire blindly." The choke modification's success extended beyond individual engagements. Squad-level tactics evolved to exploit the weapon's concentrated firepower. Assault teams developed fog formations, where choked shotgun operators provided precision fire support, while riflemen advanced under cover of limited visibility. This tactical innovation proved particularly effective during the final weeks of the war, when German defensive positions relied heavily on concealment rather than fortification. Technical analysis revealed why the choke modification proved so effective in fog conditions specifically. Fog particles scatter light and create visual distortion that makes range estimation extremely difficult. Soldiers often misjudge distances by 50% or more, leading to shots that fell short or sailed over targets. The choked barrel's concentrated pattern compensated for these range estimation errors by maintaining lethal pellet density. across a broader distance spectrum. Ballistic testing conducted at Fort Benning after the war demonstrated the modification's precision. A standard cylinder bore delivered an average of 2.3 pellets into a man-sized target at 25 yards in simulated fog conditions. The choked barrel consistently placed 4.7 pellets into the same target area. This was more than doubling the hit density. At 35 yards, the advantage became even more pronounced, with choked weapons maintaining effectiveness, while standard weapons became largely ineffective. The modification also improved ammunition efficiency, a critical factor during extended engagements. Each shell contained 9 buckshot pellets, representing significant manufacturing cost and logistical burden. By concentrating more pellets on target, the choke modification reduced ammunition consumption by approximately 40%, while increasing combat effectiveness. This efficiency gain proved crucial during the rapid advances of late 1918, when supply lines struggled to keep pace with advancing infantry. Manufacturing data from Winchester's production records revealed the precision required for consistent results. Barrel measurements varied by no more than 0.002 inches to maintain proper choke characteristics. This tolerance demanded skilled machinists and quality control procedures that exceeded most military manufacturing standards of the era. The psychological impact on both American and German forces proved as significant as the tactical advantages. American soldiers developed confidence in their ability to engage effectively during limited visibility conditions, leading to more aggressive patrol activities and assault tactics. Combat stress reports indicated reduced anxiety among troops equipped with choked weapons, as they felt capable of defending themselves, even when traditional rifle fire became ineffective. Private First Class Robert Chen, a Chinese-American soldier from San Francisco's Chinatown, described the weapon's psychological effect in a letter home. "The fog used to terrify us because we couldn't see the enemy approaching. Now we welcome the mist. It gives us the advantage. Our shotguns can find targets that rifles cannot touch." German defensive strategies adapted to counter the modified weapon's effectiveness. Intelligence reports indicated that German units began avoiding fog-shrouded areas where American forces operated, recognizing their tactical disadvantage. Some German commanders repositioned defensive lines to avoid low-lying areas where fog naturally accumulated, inadvertently ceding strategically valuable terrain. The weapon's reputation spread beyond frontline combat units. Military police adopted choked M97s for rear area security, where fog and smoke from industrial activities created similar visibility challenges. Medical Corps personnel requested the weapons for protecting field hospitals during gas attacks, when chemical clouds reduced visibility to mere feet. Training protocols evolved to maximize the choke modification's effectiveness. Marksmanship instructors developed specialized techniques for engaging targets in limited visibility, emphasizing point-shooting methods rather than traditional aimed fire. Production scaling presented unprecedented challenges for Winchester's manufacturing capacity. The company's New Haven facility operated 24 hours daily to meet military demand, with 3 shifts of workers maintaining continuous production. Each choked barrel required individual attention from skilled machinists, preventing the mass production techniques used for standard military weapons. Quality Control Supervisor Margaret O'Malley implemented inspection procedures that examined every modified barrel using precision gauges, accurate to 0.001 inches. Her team rejected barrels that deviated from specifications, maintaining the exacting standards necessary for consistent battlefield performance. O'Malley's inspection records showed that achieving proper choke dimensions required an average of 3 attempts per barrel, with many requiring complete remanufacturing. The modification's complexity created supply chain bottlenecks that military procurement officers struggled to resolve. Standard M97 production could deliver completed weapons in 48 hours from raw materials. Choked versions required an additional week for the precision machining and quality verification processes. This extended timeline conflicted with urgent battlefield demands for immediate weapon replacement. Subcontractor relationships expanded to meet production requirements, Winchester partnered with Remington Arms and Ithaca Gun Company to share manufacturing techniques and increase overall capacity. These partnerships required technology transfer agreements that shared proprietary choke specifications, representing unprecedented cooperation among competing manufacturers. Field maintenance presented additional challenges, as the precision-machined choke required specialized cleaning procedures to prevent fouling that could affect performance. Combat reports from the final months of World War I documented the choke modification's strategic impact on infantry tactics. The 1st Infantry Division's after-action reports from the Saint-Mihiel Offensive specifically credited choked shotguns with enabling successful night raids that would have been impossible with standard weapons. These raids gathered intelligence and disrupted German defensive preparations, contributing to the offensive's overall success. Tactical innovations emerged as commanders learned to exploit the weapon's capabilities. Captain William Morrison developed fog assault techniques that used natural weather conditions as tactical advantages rather than obstacles. His company achieved a 92% success rate in limited visibility operations, compared to 61% for units using conventional weapons and tactics. The modification's effectiveness extended to urban combat situations, where smoke and debris created artificial fog conditions. During the liberation of French villages, American forces found that choked shotguns provided decisive advantages in street fighting, where engagement ranges rarely exceeded 25 yards, and visibility was often compromised by burning buildings and artillery smoke. International observers took notice of the American innovation. British and French military attachés requested technical specifications and production samples, recognizing the modification's potential for their own forces. However, the war's end in November 1918 prevented widespread international adoption of the technology. Post-war analysis revealed that units equipped with choked M97s suffered 23% fewer casualties during fog-obscured engagements compared to units with standard weapons, suggesting that the modification's effectiveness provided significant defensive as well as offensive advantages. The engineering principles behind the choke modification influenced post-war firearms development across multiple nations. British weapons designers incorporated similar concepts into their military shotgun programs, while French manufacturers experimented with variable choke systems that could be adjusted for different tactical situations. The modification's success demonstrated that relatively simple engineering solutions could provide dramatic improvements in weapon effectiveness. Technical documentation from Winchester's engineering department revealed the mathematical calculations underlying the choke design. The gradual taper from standard bore to choke diameter followed a specific geometric progression that optimized shot column compression without creating dangerous pressure spikes. These calculations required slide rule computations that pushed 1918 engineering capabilities to their limits. Material science considerations proved crucial to the modification's success. The choke section required steel with specific hardness characteristics to withstand repeated firing without dimensional changes. Winchester's metallurgy department developed heat treatment processes that achieved the necessary material properties while maintaining manufacturing efficiency. Ballistic testing revealed that different ammunition types responded differently to choke modifications. Military buckshot loads achieved optimal performance with a 0.019-inch constriction, while smaller shot sizes required different choke dimensions. This discovery led to ammunition-specific choke specifications that maximized effectiveness for particular tactical applications. The modification's influence extended beyond military applications, as civilian hunters adopted similar techniques for waterfowl hunting in challenging weather conditions. Field reports from American Expeditionary Force units documented specific engagements where choked M97s proved decisive. During the Battle of Blanc-Mont Ridge, Sergeant Joseph Kowalski's squad used fog cover to approach German machine gun positions that had pinned down an entire company. His choked shotgun eliminated 3 machine gun crews in succession, each engagement occurring at ranges where standard weapons would have been ineffective due to limited visibility. The weapon's effectiveness in fog conditions created new tactical possibilities for small unit operations. Reconnaissance patrols began conducting missions during weather conditions previously considered prohibitive, gathering intelligence that proved crucial for larger operations. These patrols achieved success rates that exceeded pre-war expectations for limited visibility operations. German countermeasures evolved in response to the choked weapons' effectiveness. Intelligence reports indicated that German forces began using sound detection techniques to locate American positions, since visual identification became nearly impossible in fog. Some German units adopted similar close-range weapons, though they lacked the precision manufacturing capabilities necessary to replicate the choke modification's effectiveness. The psychological warfare aspect proved significant, as German soldiers developed specific fears about American fog fighters, who could engage effectively in conditions where traditional infantry weapons failed. Captured German documents revealed orders to avoid engagement during fog conditions, when American forces were known to be operating in the area. Medical reports documented the choked weapons' effectiveness through wound patterns that showed concentrated pellet impacts, rather than the scattered patterns typical of standard shotgun wounds. Manufacturing innovations developed for the choke modification influenced broader American industrial capabilities. The precision machining techniques required for consistent choke dimensions pushed machine tool technology forward, contributing to post-war manufacturing advances that benefited civilian industry. These techniques later found applications in automotive and aircraft manufacturing, where similar precision was required. Workforce development programs trained hundreds of machinists in precision manufacturing techniques that exceeded pre-war standards. Many of these workers transitioned to civilian manufacturing after the war, carrying advanced skills that contributed to American industrial growth during the 1920s. The training programs established at Winchester became models for technical education programs at other manufacturers. Quality control procedures developed for choke manufacturing established new standards for military weapons production. The inspection techniques and measurement protocols created for the M97 modification influenced manufacturing standards across the American defense industry, improving overall weapon reliability and performance. Supply chain management innovations emerged from the challenges of producing precision-modified weapons under wartime pressure. Winchester developed new scheduling and inventory management techniques that optimized production flow while maintaining quality standards. These management innovations influenced post-war manufacturing efficiency across multiple industries. The economic impact extended beyond direct manufacturing costs, as the modification's effectiveness reduced ammunition consumption and medical costs associated with combat casualties. International recognition of the choke modification's effectiveness led to post-war technology transfer agreements with allied nations. The British War Office negotiated licensing agreements for the choke specifications, planning to incorporate the technology into their post-war military shotgun programs. French manufacturers requested technical assistance to develop similar modifications for their own weapon systems. Diplomatic implications emerged as the modification's effectiveness became widely known. German military observers studying captured American weapons recognized the technological advantage represented by the precision manufacturing capabilities required for consistent choke production. This recognition influenced post-war German industrial development priorities as they sought to match American manufacturing precision. The modification's success contributed to American military prestige and influenced international perceptions of American technological capabilities. Military attachés from neutral nations requested demonstrations of the choked weapons, recognizing their potential applications for their own defense forces. Academic institutions began studying the engineering principles underlying the choke modification, leading to research programs that advanced understanding of ballistics and precision manufacturing. These research efforts contributed to broader scientific knowledge that benefited both military and civilian applications. The technology transfer process revealed the complexity of sharing precision manufacturing techniques across different industrial systems, as each nation's manufacturing capabilities required adaptation of the basic choke principles. Combat effectiveness studies conducted after the war provided comprehensive data on the choke modification's impact. Statistical analysis of engagement outcomes showed that units equipped with choked weapons achieved mission success rates 47% higher than units with standard weapons during limited visibility operations. These studies became foundational documents for post-war military doctrine development. Tactical doctrine evolution reflected the lessons learned from choked weapon employment. Military training programs incorporated fog fighting techniques that maximize the modification's advantages, teaching soldiers to use weather conditions as tactical assets rather than obstacles. These training programs influenced military education for decades after the war's end. The modification's success influenced weapon development priorities for future conflicts. Military planners recognized that technological advantages could emerge from relatively simple engineering improvements, rather than revolutionary new weapon systems. This understanding shaped procurement strategies and research priorities throughout the interwar period. Veteran accounts provided qualitative data that complemented statistical analysis. Former soldiers consistently reported increased confidence and effectiveness when equipped with choked weapons, particularly during challenging weather conditions. These accounts influenced military psychology research and training program development. The comprehensive documentation of the choke modification's effectiveness established new standards for military technology evaluation, requiring quantitative measurement of performance improvements rather than subjective assessments. The choke modification's influence on post-war civilian firearms development proved substantial and lasting. Sporting goods manufacturers adopted similar precision manufacturing techniques for hunting shotguns, improving civilian weapon performance, and establishing new market standards. The technology transfer from military to civilian applications demonstrated the broader economic benefits of military research and development. Hunting guide services began advertising specialized fog hunting expeditions, capitalizing on the improved effectiveness of choked weapons in challenging weather conditions. These services attracted wealthy sportsmen who sought the ultimate hunting challenge, creating new economic opportunities in rural areas where fog conditions were common. Competitive shooting sports evolved to incorporate precision shotgun events that showcase the accuracy improvements possible with proper choke modifications. These competitions drove further innovation in choke design and manufacturing techniques, creating a civilian market for precision firearms technology. Educational institutions established programs to study the ballistics principles underlying choke effectiveness, contributing to broader scientific understanding of projectile behavior, and influenced post-war research in ballistics and atmospheric physics. The modification's success story became a case study in engineering schools, demonstrating how careful analysis of operational requirements could lead to simple but effective technological solutions. Medical Corps reports documented the choke modification's impact on battlefield medicine through analysis of wound patterns and casualty rates. The concentrated pellet patterns produced by choked weapons created more decisive wounds that required less medical intervention, reducing the burden on field hospitals during major offensives. This medical efficiency proved crucial during periods when medical resources were stretched beyond capacity. Psychological studies of combat effectiveness revealed that soldiers equipped with choked weapons demonstrated measurably lower stress levels during limited visibility operations. The confidence provided by effective weapons reduced combat anxiety and improved overall unit performance. These findings influenced military psychology research and contributed to understanding of weapon effectiveness's psychological dimensions. The modification's impact on ammunition logistics proved significant, as the improved hit probability reduced ammunition consumption by an average of 38% during fog operations. This efficiency gain reduced supply line pressure and allowed units to operate for extended periods without resupply, improving operational flexibility. Training efficiency improved as soldiers learned to use choked weapons effectively in shorter time periods compared to standard weapons. The concentrated shot patterns provided immediate feedback on shooting technique, accelerating skill development, and reducing training ammunition requirements. The comprehensive documentation of these benefits established the choke modification as a model for military technology development, demonstrating the importance of considering all aspects of weapon effectiveness rather than focusing solely on basic performance metrics. Intelligence reports from captured German documents revealed the enemy's recognition of the choke modification's tactical significance. German military analysts correctly identified the modification as a force multiplier that provided American units with disproportionate advantages during specific weather conditions. These analyses influenced German defensive strategies and contributed to their decision to avoid engagement during fog conditions when possible. Counterintelligence efforts by German forces focused on capturing examples of choked weapons for reverse engineering attempts. However, the precision manufacturing requirements proved beyond German industrial capabilities under wartime conditions, preventing effective replication of the technology. This technological gap contributed to German tactical disadvantages during the war's final months. The modification's effectiveness influenced German post-war military planning, as they recognized the need to develop similar precision manufacturing capabilities to remain competitive in future conflicts. This recognition shaped German industrial development priorities during the interwar period. Allied intelligence services documented German attempts to develop countermeasures for the choked weapons, including experimental ammunition designed to maintain effectiveness in fog conditions. These countermeasures proved largely unsuccessful, demonstrating the fundamental advantage provided by the American modification. The intelligence value of the choke modification extended beyond its direct military effectiveness, as it demonstrated American technological capabilities and influenced international perceptions of American military potential. Economic analysis of the choke modification's impact revealed significant cost-effectiveness advantages that influenced military procurement decisions for decades. The modification cost approximately $12 per weapon in 1918 currency, while providing effectiveness improvements that would have required much more expensive alternative solutions. This cost-benefit ratio established new standards for military technology evaluation. Production efficiency studies showed that the precision manufacturing techniques developed for choke production improved overall Winchester factory productivity by eliminating waste and improving quality control procedures. These efficiency gains reduced production costs for all weapons manufactured at the facility, demonstrating the broader benefits of precision manufacturing investment. The modification's success influenced military budget allocation priorities, as procurement officers recognized that relatively small investments in weapon improvements could provide substantial operational advantages. This understanding shaped military spending patterns and research priorities throughout the interwar period. Labor productivity improvements resulting from the precision manufacturing training required for choke production created lasting benefits for American industrial capacity. Workers trained in these techniques carried advanced skills to civilian employment after the war, contributing to American manufacturing competitiveness. The economic impact extended to ammunition manufacturers, as the improved hit probability reduced overall ammunition demand while maintaining or improving combat effectiveness, influencing industry production planning and capacity allocation. Environmental factors that influence the choke modification's effectiveness became subjects of detailed study by military meteorologists and tactical analysts. Fog density, humidity levels, and temperature variations all affected the modification's performance characteristics, leading to development of weather-specific tactical guidelines that maximized effectiveness under different conditions. Geographic analysis revealed that certain terrain features enhanced the choke modification's tactical advantages. River valleys, coastal areas, and industrial regions where fog occurred frequently became preferred areas for American operations, as units could exploit their technological advantage. This geographic preference influenced strategic planning and unit deployment decisions. Seasonal patterns of fog occurrence influenced operational timing, as commanders learned to coordinate major offensives with weather conditions that favored their choked weapons. This weather-dependent tactical planning represented a new dimension of military strategy that considered technological capabilities alongside traditional factors. The modification's effectiveness in urban environments, where smoke and debris created artificial fog conditions, expanded its tactical applications beyond natural weather phenomena. This versatility proved valuable during the liberation of French and Belgian cities, where street fighting created ideal conditions for choked weapon employment. Scientific study of the ballistic principles underlying the modification's effectiveness in various atmospheric conditions contributed to broader understanding of projectile behavior and influenced post-war research in ballistics and atmospheric physics. Training program development for choked weapon employment created new military education standards that influenced instruction methods for decades. The specialized techniques required for maximum effectiveness demanded training programs that combined traditional marksmanship with weather-specific tactical skills. These programs establish new benchmarks for military training comprehensiveness and effectiveness. Instructor qualification requirements evolved to ensure that training personnel understood both the technical aspects of choke modifications and the tactical applications that maximize their effectiveness. This instructor development process created a cadre of specialists who continued to influence military training long after the war's end. Simulation techniques developed for training soldiers in fog fighting tactics pioneered new approaches to military education that replicated combat conditions more accurately than traditional training methods. These simulation techniques influenced training program development across multiple military specialties. Performance measurement standards established for choked weapon training created new metrics for evaluating soldier proficiency and unit readiness. These standards provided objective measures of training effectiveness that improved military education quality and consistency. The comprehensive training documentation created for choked weapon programs became models for military instruction in other specialized weapon systems, establishing new standards for training program development and implementation. Technological heritage of the choke modification extended far beyond its immediate military applications, influencing firearms development, precision manufacturing, and military procurement strategies for generations. The engineering principles underlying the modification continued to influence weapon design throughout the 20th century, demonstrating the lasting value of fundamental technological innovation. Manufacturing techniques developed for choke production contributed to American industrial leadership in precision manufacturing, providing competitive advantages that extended across multiple industries. The quality control procedures and measurement techniques pioneered for the modification established new standards that influenced manufacturing excellence throughout American industry. The modification's success story became a case study in military innovation, demonstrating how careful analysis of operational requirements could lead to simple but revolutionary improvements in weapon effectiveness. This lesson influenced military research and development priorities and established new approaches to technology development. International recognition of American technological capabilities, enhanced by the choke modification's success, influenced diplomatic relationships and military cooperation agreements throughout the interwar period. The modification became a symbol of American engineering excellence and military innovation. The comprehensive documentation of the modification's development, production, and employment created a knowledge base that continued to influence military technology development long after the specific weapon became obsolete, establishing new standards for technology transfer and institutional learning. As the fog lifted over the Western Front on November 11, 1918, revealing the silent trenches and abandoned battlefields of a war finally ended, the true measure of the M97's choke modification became clear. In the span of just 4 months, this seemingly simple engineering solution had fundamentally altered the dynamics of infantry combat, proving that technological innovation could emerge from careful observation of operational challenges rather than revolutionary breakthroughs. The modification's success lay not in its complexity, but in its elegant simplicity. This was a slight constriction of metal that doubled hit density when soldiers needed it most. The lesson resonated far beyond the muddy battlefields of France. Sometimes the most profound military advantages come not from reinventing warfare, but from perfecting the tools already in hand.